Okay, so I think it's time for us to look at an example. A reflector is attached to a bicycle wheel at a point about 17 centimeters from the center of the wheel. The radius of the wheel is approximately 30 centimeters. The wheel rotates clockwise and takes 4 seconds to complete one revolution. Assuming that the reflector is at the topmost position at time equals 0, develop a model for the height h of the reflector above the ground at any time t in seconds. In case you don't really know what they're talking about in terms of a reflector, here is a picture of a bicycle wheel. Notice that we have, this would be our reflector right here. And in this particular image that I'm using here, there's two reflectors. Well, there's one at the top and there's one at the bottom. Let's go ahead and ignore the one at the bottom and let's just only work with this one right here at the top, okay? Then I'm going to go ahead and shade in black. Basically, what they're telling us in the problem is that it is attached to the bicycle wheel at a point 17 centimeters from the center of the wheel, and the radius of the wheel is 30 centimeters. So that means that this reflector from the center right here is 17 centimeters. And the radius, meaning going all the way down to the end, that radius is going to be 30 centimeters. So this wheel is traveling clockwise in this direction, and it's traveling 4 seconds per revolution. A revolution is when it goes all the way around. This is one full revolution when it completes a full circle. So that's happening every 4 seconds. So that means that after every second, it's moving in position. So this is basically the idea of what is happening in this problem. You have this reflector, which is starting up at the top, and then the reflector is moving clockwise. Notice that it's going to move after 1 second. The reflector on the right, that's the position it's going to be. Then it's going to move again. And in another second, it's going to find itself down at the bottom. It's going to move again. This time, after the 3rd second, it's going to find itself on the left. And then it's going to find its way right back to the top. So this motion, okay, except for the fact that the wheel would not be moving in size, but just for the demonstration, you get an idea of what is happening. The wheel is moving clockwise and the reflector is going to be shifting positions. It's going to be up, it's going to be to the right, it's going to be down, it's going to be to the left, it's going to go right back up. And that's basically what we're trying to figure out in this problem and try to come up with a model for it. So in order for us to do this, we are going to have to stop and think about what is happening in our graph. We're going to set up a table of values where we're going to have time versus height. So at time 0, right now we're starting with the reflector at the top. What is the height from the ground? So right here we have the ground, okay? What is the height from the ground that you're going to see this reflector? So it's going to have to be 30 plus 17 because the reflector is this whole part right here. So 30 plus 17 is going to be 47. So at time 0, the height of the reflector is 47. Then what happens after 1 second? After 1 second, the reflector is going to turn and it's going to now be sideways. So the reflector is going to look like this. And remember, from the center going down, this is going to be 30. So the reflector right now is at a height of 30 from the ground. So at time 1 second, we are at 30. What happens as we continue turning? At time 2 seconds, now the reflector is going to be down here at the bottom. Okay, so what is going to be the height from the ground of the reflector at that point? Here's the ground right here. If you remember, we said that the entire radius from the center going all the way down to the ground is going to be 30 centimeters. And we also said that from the center to the reflector, this part right here in blue is 17 centimeters. So that means that this other part that's left over, it has to be 30 minus 17, which is 13. Now, on the picture that I'm using, 17 and 13 don't look like they're in proportion. Okay, so bear with me here because this is the best reflector picture that I could find for this purpose. But what you basically are seeing is that you have a circle where the radius of the circle is going to be 30. The reflector is up here at a distance of 17, and then it's rotating so that it ends up here, and then now it's down at the bottom. This distance is still 17, so what's missing to add up to 30 is going to be 13. So at time 2 seconds, we're at 13. Okay, so once again, notice what happens when the reflector is back to being on the left-hand side after 3 seconds. What's the height that it is? Well, from the center going all the way down, the radius is 30, so the height of the reflector down to the ground is also going to be 30. So at time 3 seconds is at 30. So then before you know it, 1 second later, you're back to where you started. So after 4 seconds, it's completed 1 full revolution and you're back to being at 47. If I were to graph this on a graph, here is my time, here is my height. I'm going 1 second, 2 seconds, 3 seconds, 4 seconds, because this 1 full revolution is happening basically every 4 seconds. In terms of height, I'm at 13, 30, or 47. So I'm going to start at time 0, I'm at 47. At time 1, I'm at 30. At time 2, I'm at 13. At time 3, I'm at 30. And at time 4, I'm at 47. All I'm doing is graphing the points that I figured out every single time that I rotated my wheel. Okay, so I basically grabbed these as my ordered pairs and I went ahead and I plotted them. So now notice that this resembles a sine graph or a cosine graph. If you said cosine graph, you are correct. Also notice that our principal axis right here, the line that's going to cut this in half, is occurring at 30. What that tells me is that our equation, y equals a cosine of bx plus d, I already know that d has to be 30 because that's where the principal axis is going to be. So I know that d is 30. A is the amplitude. In order for me to determine the amplitude is half the distance between the maximum and the minimum. So 47 minus 13, that is going to be 34, and half of that is 17. So I know that the amplitude is going to be 17. So far I have y equals 17, the cosine of, I haven't figured out b yet, and then it's going to be plus 30. Another way that I can figure out the amplitude is to just start from the principal axis, which is right here, and go to the maximum. So how much space is it from the principal axis to the maximum? 17. So once again, I already confirmed that the amplitude is 17. Okay, so what I have left to do is to figure out b. Remember that b is not the period. But if I take 360 and I divide it by b, that is going to equal the period, okay? Divided by the absolute value of b. Notice in the graph, what is the period? How long does it take for me to complete 1 full revolution? It takes me 4 seconds. So in our problem, in our example, the period is 4 seconds. That is how long it's going to take to complete 1 full cycle. If I want to figure out the value of b, 360 divided by some number, it's going to give me 4. So think about it. 360 divided by what number is equal to 4? The answer is 90. 360 divided by 90 is 4. So that means that I can finish off my equation by writing 90x. So the equation that's going to represent this situation is going to be y equals 17 cosine 90x plus 30.